Welcome all of you in your channel. Don't forget to support us by subscribe and activating the notification bell. We're not going to linger in the lead so much, so let me ask you. What if you knew that we don't exist, or that we exist on a planet other than Earth? Or even that you are a king in a kingdom as if you are in a world parallel to ours? Continue until the end of the episode and you will be satisfied with the things we just mentioned. The story began when Albert Einstein discovered that light consists of small particles of energy called photons. But scientific theories had already proven that light are waves. Well, let me tell you that Einstein's words are correct because all his tests passed, but also the words of the scientists are correct, and all of their tests passed. Here we came to the conclusion that light is composed of photons as well as waves, and this is what was called later, the diminutive nature of light. Meaning that light sometimes behaves like a wave and sometimes it behaves as particles, and this matter depends on the tests that were conducted on the light. In 1429, the scientist Louis Victor de Broglie confirmed that electrons also have a dipole nature. As we know, the atom is made up of small particles called protons and neutrons that represent the nucleus of the atom. And around these particles spin electrons that were found to have the same properties of light. Sometimes it shows wave nature and other times it shows particle nature. And later it has proven that all the atoms that make up matter obey the same law and have the same property of light and electrons. After all this, the Austrian scientist Erwin Schrödinger appeared to put an end to the debate and established the following equation, which is the basis of quantum mechanics. Well, don't worry, we won't go into the details of this equation, and we will simplify it in its simplest form in the following way. Imagine that you have an electron, and this electron has the property of spinning. Meaning that it may rotate to the right or left, but if we put this electron behind a barrier so that we can't see it, we won't know which direction it is spinning. Is it to the right or is it to the left? Schrödinger's equation tells us that this electron rotates to the right and left at the same time as long as we don't see it. And when we remove the barrier, one of the two states falls and the other remains, so when we remove the barrier, either the electron rotates to the right or to the left. It is that simple. It's not that simple, and certainly there are many questions on your mind that I will answer you now. How does an electron rotate left and right at the same time? That is the question, right? Let me tell you that the scientific community hasn't provided an adequate answer to this question. The topic is very complex, as if I'm telling you that these eyes are closed and open at the same time, and this person is looking left and right at the same time. Due to the complexity of the topic, some scholars have called this case a Chast-like state, and when looking at it and adopting one pathway we call it Copenhagen interpretation. Well, I know that this explanation is very difficult, cause how can an electron turn left and right at the same time, but believe me, all the questions about how or what or why, it didn't have a completely specific answer. And all scientists were very happy with this explanation and this equation that Schrödinger put forward, so based on it they were able to explain many questions such as the duality nature of light. If we take the simplest possible example of this equation, and we all imagine that there is an electron connected to a circuit and this circuit is connected to a poisonous gas. And this poisonous gas is connected to a cute mouse like this. Now if the electron turns to the right, the circuit will open. And from it the toxic gas will be released. And the poor mouse will die. But if the electron turns to the left, the circuit won't open. And the mouse will live. Now if we put all these things inside a small room and closed it, so we don't know what is happening inside the room, then the Schrödinger equation tells us that the electron is rotating to the right and left at the same time. And the circuit is open and closed at the same time. meaning that the mouse is alive and dead at the same time, and if we don't enter the room we won't know if the mouse is alive or dead. This interpretation developed by Schrödinger helped us to know the nature of electrons and photons, that is very small particles. But Schrödinger's goal was to reach only one question, which is if we tried to include larger organisms such as humans and living things, would this interpretation apply to them? The answer was as follows. As we know, atoms are the basic component of all things that exist in this life, and if we take for each atom the number of states that its electrons and protons can take, we will find that we are facing an infinite number of states. Let's explain this in our easy simplified way. If we go back to our friend the mouse and consider for ease that this mouse is made of two atoms, atom 1 and atom 2, and that these two atoms have red and blue colors. We put our friend in the same room and closed it without knowing what is happening inside it. According to the Schrödinger equation, the atoms of this mouse are either corn 1 red, corn 2 blue, or corn 1 blue and corn 2 red. Or the two atoms are red, or the two atoms are blue, meaning that this mouse is present in 4 cases when I don't look at it, and when I look at it, 3 states of it fall and remain only 1 case. This simple example was about the mouse consisting of only 2 atoms, but what if we tried to apply the equation to the human being composed of this number of atoms? And if every atom has 2 states, we will find ourselves in front of an infinite number of states. And after the human, what if we tried to apply this equation to the entire universe that was formed from an infinite number of atoms as well? In other words, it is possible that in a state of the universe we are on a planet other than Earth, and that you are a king in an empire, or that the girl you like has agreed to join you, and we may not exist at all. And all these cases fall when we look at the universe and ourselves. It's similar to the series Dark in Complexity, right? But let's end our episode with a question. When we sleep, does the universe disappear? As we know, states fall when we look at them, but what happens when we are asleep? Is it possible that we stop on a parallel world and the dream is another life for us in one of our situations? Frankly, dear viewer, the truth is that all facts fall into the world of quantum mechanics. So the thing that I want from you now is to make sure you exist. The quantum world is vast and may not be subject to our normal laws and has many possibilities, such as being a superhero or going out with your lover on a date, or that you are a sailor or pilot or whatever your status is infinite. Here, we reach the end of our episode, and we hope you like it.